Recap. Before we move forward, let's quickly recap what we've learned so far. We started by understanding how enterprise networks have evolved from traditional on-premises environments to cloud-first architectures. We discussed why traditional firewalls struggle to secure cloud applications. We explored the concept of shadow IT and saw how employees can unintentionally expose company data by using unauthorized SaaS applications. Finally, we introduced CASB and learned that it acts as a security broker between users and cloud services. Now it's time to go deeper. Let's understand exactly how CASB works behind the scenes. How CASB works: the complete request lifecycle. Imagine you're an employee working from home. Your laptop is connected to your home Wi-Fi. You open your browser and access Microsoft 365 to upload an Excel file containing customer information. At first glance, it looks simple. You click Upload, and the file appears in OneDrive. But behind the scenes, many security checks happen in just a few milliseconds. Let's walk through the complete flow. Step 1. User authentication. The first question the enterprise asks is, who is this user? Instead of trusting the username alone, CASB integrates with an identity provider, IDP, such as Microsoft Entra ID, formerly Azure AD, Okta, Ping Identity, Google Cloud Identity. The identity provider verifies username and password, multi-factor authentication, MFA, user group, department, role, device identity, conditional access policies. At this point, the user has proven who they are, but authentication alone is not enough. Now the enterprise needs to determine what this user is allowed to do. Step 2. Device validation. The next question is the device trusted? Imagine two scenarios. Scenario A. Alice logs in from her company-issued laptop. The device is encrypted, has antivirus installed, has the latest operating system updates to IS managed by the company's endpoint management solution. This is a trusted device. Scenario B. Now imagine Alice logs in using a personal laptop. The device has no antivirus to IS, missing security patches, has unknown software installed .is unmanaged. Even though Alice is the same user, the risk level is completely different. A modern CASB can use device posture information to apply different security policies. For example, allow full access from managed devices, allow read-only access from unmanaged devices, block file downloads to personal devices, require re-authentication before sensitive actions. Identity and device posture together provide much stronger security than passwords alone. Step 3. Application discovery. Now CASB asks another important question. Which cloud application is being accessed? Is the user connecting to Microsoft 365, Salesforce, Google Workspace, ServiceNow, Dropbox, GitHub, AWS Management Console? CASB identifies the application and checks whether it is approved by IT restricted high-risk unknown shadow IT. This visibility is one of CASB's greatest strengths. Step 4. User activity analysis. Now CASB begins inspecting the actual user action. The user may be trying to upload a file, download a document, share a folder, delete files, create a public link, change permissions, export customer records, invite external users. Notice something important. A firewall generally sees encrypted HTTPS traffic. CASB understands the business activity taking place inside that encrypted session. That's a significant difference. Step 5. Content inspection. Now comes one of the most powerful capabilities of CASB. It inspects the content itself. Suppose Alice uploads an Excel spreadsheet. CASB scans the file and asks questions such as, does it contain customer names, credit card numbers, passport numbers, employee salary details, healthcare records, source code, intellectual property? This process is commonly integrated with data loss prevention, DLP, technologies. Instead of treating every file the same, CASB understands the sensitivity of the data. Step 6. Policy evaluation. Now the enterprise security policies come into play. Think of this as the decision-making engine. The CASB evaluates questions like, is the user in the finance department? Is the upload destination approved? Is the device managed? Is the user working from a trusted country? Is the file classified as confidential? Is sharing allowed with external users? Is the application sanctioned by IT? Every organization defines its own policies based on business and compliance requirements. Step 7. policy enforcement. Finally, CASB takes action. Depending on the policy, it can allow the activity, block the activity, encrypt the file, remove sensitive information, quarantine the file, generate an alert, require additional authentication, notify the Security Operations Center, SOC. All of this typically happens within milliseconds, providing real-time protection without significantly impacting the user experience. CASB Architecture. Now let's visualize where CASB fits into the enterprise architecture. Imagine the following flow. User. Manage device/browser. Identity provider, IDP. CASB. Policy engine, DLP engine. Threat detection, compliance engine. Activity monitoring. Cloud applications. Microsoft 365. Salesforce. Google Workspace. ServiceNow. Dropbox. AWS. Azure. Let's understand the role of each component. User. Initiates access to a cloud application. Manage device. Provides device posture information such as compliance status, antivirus health, encryption, and operating system version. Identity provider. Authenticates the user and supplies identity attributes like department, role, group membership, and MFA status. CASB. Acts as the intelligent security layer that evaluates identity, device posture, application, user activity, and content before making an access decision. Cloud application. Receives only the requests that comply with enterprise security policies. Two major CASB deployment models. Organizations generally deploy CASB in one or both of the following ways. 1. Inline CASB, proxy-based. Think of an airport security checkpoint. Everyone passes through it before boarding. Similarly, in an inline deployment, all traffic flows through the CASB before reaching the cloud application. User. CASB proxy. Microsoft 365. Advantages. Real-time inspection, immediate blocking, real-time DLP, instant malware detection, immediate policy enforcement. Limitations. Requires traffic steering. May introduce minimal latency if not designed properly. Needs careful SSL/TLS inspection planning. Inline CASB is ideal when organizations want to stop risky actions before they happen. 2. API-based CASB. Now consider a different approach. Instead of inspecting traffic as it travels, the CASB connects directly to the cloud provider using official APIs. Microsoft 365. API integration. CASB. The CASB periodically examines stored files, user activities, sharing permission, security, settings, historical events. Advantages. No traffic redirection, easy deployment, excellent visibility into existing cloud data, can discover historical security issues. Limitations. Not all actions can be blocked in real time. Some enforcement occurs after the event. Inline versus API, which is better? A common interview question is, which deployment model should we choose? The answer is, it depends on the organization's requirements. If you need immediate blocking, real-time DLP, instant malware prevention, an inline deployment is usually the better choice. If you need visibility into existing cloud data, compliance reporting, historical analysis, easier deployment, API integration is often sufficient. In practice, many large enterprises use both. Inline CASB provides real-time protection, while API-based CASB continuously audits cloud environments and identifies risks that may already exist. This layered approach delivers comprehensive cloud security. Enterprise example, end-to-end flow. Let's bring everything together with a real-world scenario. Imagine a multinational financial organization. An employee in the finance department is working remotely. They access Microsoft 365 using a company-issued laptop. Before allowing a file upload, the following sequence occurs. The user authenticates through Microsoft Entra ID with MFA. The endpoint management platform confirms the laptop is compliant, that CASB identifies that the destination is Microsoft OneDrive. The uploaded spreadsheet is scanned, that DLP detects customer account numbers and financial records. Company policy states that confidential financial data cannot be shared outside the corporate tenant. CASB blocks the upload. A security alert is sent to the SOC team. The event is logged for compliance and auditing. Notice how multiple technologies work together. Identity, endpoint security, DLP, and CASB all contribute to protecting sensitive information. Now that you understand how CASB works internally, you're ready for the next step. In Part 3, we'll answer the questions that confuse many engineers and interview candidates. Is CASB the same as SASE? How is CASB different from SWG? What is the difference between CASB and ZTNA? Does CASB replace a firewall? Where exactly does CASB fit within a SASE architecture? How do all these security services work together in a real enterprise? By the end of Part 3, you'll have a clear mental model of the modern SASE security stack and be able to explain these concepts confidently in both enterprise projects and technical interviews. If this video helped you understand the difference between CASB and SASE, please give it a thumbs up and share it with your colleagues. If there is a specific topic you'd like to see next, let me know in the comments. Thank you for watching. Thank you for learning with SASE Cloud Networking, and I'll see you in the next Enterprise Networking Deep Dive.